Something is wrong with the Milky Way. About 4,000 light-years from Earth, in the Sagittarius spiral arm, astronomers have discovered a massive fracture, stretching over 3,000 light-years. Vast clouds of gas and entire clusters of stars are breaking the Milky Way's rotation rules, shooting outward at a bizarre angle like something has violently torn them away. Now scientists are asking a terrifying question. Is the Milky Way starting to break apart? And more importantly, could our solar system face the same fate? Using the most hardcore observational data, I'm going to take you inside what might be a galaxy-scale cosmic fracture event. And by the end, you'll realize something unsettling. The Milky Way we thought we understood is hiding far more shocking and mind-breaking truths than we ever imagined. In fact, humanity may understand distant galaxies better than our own. Have you always thought that the Milky Way is a perfectly symmetrical barred spiral galaxy with 4 smooth spiral arms, like elegant pinwheels spinning in space? That is actually incorrect. We are located inside the Milky Way, and everything we can see is filled with dense, interstellar dust and gas. These act like thick, impenetrable walls that block visible light. Even the appearance of the galactic center took us over 100 years to observe with some clarity. Over the past century, scientists have had to rely on radio telescopes to detect radiation that can penetrate the dust, or track a small number of bright young stars, gradually piecing together the structure of the Milky Way, much like trying to understand an object by touching only parts of it. In traditional galactic models, the spiral arms of the Milky Way are expected to be very smooth, like ribbons tightly wrapped around the galactic disk. The pitch angle of the Sagittarius Arm is only about 12 degrees, making it appear stable and well-ordered. When scientists input these data into supercomputers to reconstruct a realistic three-dimensional model of the Milky Way, everyone involved was deeply surprised. In a specific region of the Sagittarius Arm, what should have been a smooth and continuous galactic structure instead shows a dramatic and abrupt distortion. A structure composed of dense gas, dust, and hundreds of thousands of young stars has deviated completely from the normal pitch angle of about 12 degrees, extending outward at an angle of nearly 60 degrees. This anomalous structure is enormous, spanning approximately 3,000 light-years. To put that into perspective, the diameter of our solar system is at most about 1 light-year, meaning that this feature could contain roughly 3,000 solar systems in length, and it includes hundreds of thousands of stars. Even more striking, data from the Gaia Space Observatory indicate that the stars and gas within this structure are moving together in the same direction and at similar speeds along the 60-degree inclination, largely deviating from the overall rotational pattern of the Milky Way. What is also remarkable is that within this 3,000 light-year-long region lie some of the most well-known deep sky objects ever captured in astronomical imaging. For example, the Eagle Nebula and its famous pillars of creation are located along the edge of this structure, where intense ultraviolet radiation is actively shaping newly forming star systems. This discovery has significantly challenged astronomers' previous understanding of the structure of the Milky Way. Everyone is asking the same fundamental question. What kind of force could break a spiral arm spanning thousands of light years? So far, there is no unified conclusion in the scientific community. However, 3 highly plausible physical hypotheses have been proposed, each offering a different perspective on the dynamic processes at work in the galaxy. The first and most widely accepted explanation involves a local breakdown of the density wave theory. In modern astronomy, spiral arms are not considered fixed structures made of permanently bound stars, but rather regions of higher density, similar to waves. A simple analogy is a traffic jam on a highway. As stars and gas orbit the galaxy, they slow down and compress in certain regions, forming bright spiral arms. After passing through these, they continue moving on. The overall shape of the spiral arm remains, but the individual stars within it are constantly changing. In this case, it is possible that an unknown disturbance disrupted the local density wave, causing a loss of stability in its dynamics. This may have resulted in a large-scale outflow at an angle of about 60 degrees, forming the observed structure. The second hypothesis involves the interaction between magnetic fields and gravity. In regions filled with ionized gas, the large-scale magnetic field of the galaxy plays an important role. As massive interstellar molecular clouds collapse under their own gravity to form stars, galactic magnetic fields can resist this collapse. At certain points, the competition between these forces can become extremely intense. This may lead to distortions and reconnections in magnetic field lines, ejecting vast amounts of matter and stars at unusual angles. and forming a structure extending thousands of light years. The third hypothesis, which has some observational support, suggests an external impact event. The Milky Way is not an isolated system. It has interacted with and absorbed smaller galaxies over billions of years. One such neighboring system, the Sagittarius dwarf elliptical galaxy, is currently being disrupted by the Milky Way's gravity and has already passed through the galactic disk multiple times. Scientists propose that millions or even hundreds of millions of years ago, its dark matter halo may have passed through this region at high speed, creating a significant gravitational disturbance. The large structure we observe today could be a lingering effect of that event. At this point, you might ask, is the Milky Way actually breaking apart? The answer is no. It is not breaking apart, but rather revealing a more complex and dynamic structure than we previously understood. What we can do is continue observing and exploring, gradually improving our understanding of the galaxy we inhabit, because even now, we have not fully understood the Milky Way itself.